Hey guys, Krishna here, and in this video I'm going to say how to solve a quadratic equation. The first one, it is an identity, which means there are some problems which are based on totally algebraical identities like a plus b whole square, a minus b whole square. A plus b whole square is a square plus b square plus 2ab, and a minus b whole square is a square plus b square minus 2ab, and the another one is a plus b into a minus b is a square minus b square. Majorly every question basing on the identity comes from these three identities. Let me tell you a problem. The first one is, for suppose there is a problem asking for solving for x. X square is equal to 9, which means x is equal to 9. Now putting a square root on both sides, we get an x here and we get plus or minus 3 here, as 3 square is 9. Remember, for a quadratic equation we have two roots. It may be any equation and there is no specific rule that it must be equal or it must be having equal magnitude or etc. Problem number 1. The equation given is x square minus 8x plus 16. If you observe it carefully, we have this one 16, which is equal to 4 square, and by getting a relation here we get like 2 into x into 4 plus 4 square is equal to 0. This is in the form of a minus b whole square. A square, b square, 2ab minus 2ab, which means this is indirectly equal to x minus 4 whole square, which is equal to 0. Now removing the square, x minus 4 is equal to 0 and x is equal to 4. Easy, isn't it? Now the second one. If at all we are given a problem which is not basing on identity, then the second step is to check whether it can be factorized. What do you mean factorized? It means if there is a quadratic equation, here is the standard form of quadratic equation, ax square plus bx plus c is equal to 0. If it can be written in the form of x minus a into x minus b equal to 0 or not. How to check? I am going to say that now. The first step is to multiply the coefficient of x square and the constant term. Remember, with the sign minus 2, if we got minus 2 here, then it is minus 2. The term is minus 2. Multiply then. 9 into minus 2 gives you 18, and plus into minus is minus. The second step, write it down aside. Now the third step is to find a pair when multiplied gets minus 18 and when summed up will give you minus 3. I am repeating it again. We have to find a pair when multiplied should get minus 18 and when summed up it should be minus 3. Why? Because if a pair exists such that it satisfies this condition, then it is factorized. If not, it is not factorized. So let's check. 18, 1 into 18, 2 into 9, 3 into 6, and the remaining is the same. It comes in the reverse order. 6 into 3, 9 into 2, and 18 into 1. It is minus symbol, so we can put minus either here or here. It's your wish. Now summing up, 18, 1, 2, 9 are not at all in the picture, and 6, 3. 6 minus 3 gives you 3, but we need minus 3. So minus 6 plus 3 gives you minus 3, and minus 6 into 3 gives you minus 18. So the pair we are looking for is 3 comma minus 6. Clear? And then just split it down. Minus 3x, just split it down into minus 6x and plus 3x. Remaining is the same, minus 2 is equal to 0. And then what you need to do is to take out anything which is common in the given expression. First, suppose we have x here and we have x square here. X square mean that x into x, which means we have x common, and 9 and 6. By default we can know that 3 2s are 6 and 3 3s are 9. So 3 is common. Taking out the common, 3 into 3 is 9, remaining is x, minus 3 into 2 is 6, x common, so as it is, plus. In this one we don't have anything in common, but we have the ultimate number, number 1. Any expression number 1 can be taken out as common. 3x minus 2. Now look at this. We have two terms, and in these two terms we have this one 3x minus 2 in common. Take it out. 3x minus 2, and we get 3x and plus 1. Clarified? And then the last step is to take any one term to the RHS so that one becomes 0 or the other becomes 0 and x becomes 2 by 3 or x becomes minus 1 by 3. And this is the factorization method which you need to do if at all there is no identity. And the process seems to be big, but after practice it seems easier. Till now we have seen two types, identity and factorize. Now this one is rearranging and factorizing. First, we need to rearrange the equation so that we get a quadratic equation. How to rearrange? Just sum it up. 6x square plus 10 by x is equal to 23. And sending this x to the right hand side, 6x square plus 10 is equal to 23x. And sending this to LHS, 6x square minus 23x plus 10 is equal to 0. Repeating the procedure, we get the pair as 3, 20. And to be specific, it is minus 3, minus 20. Taking out common, we get 3x common here. 3x of 2x minus 1, and we get 10 common here, and I will take out minus 10 because I need to get minus in the second term, not in the first term. So I will take out minus 10, so minus becomes plus 2x and this becomes minus 1. The same thing, 2x minus 1 and 3x minus 10. 2x minus 1 common and 3x minus 10 is remain. Equating each term to 0. 2x minus 1 is equal to 0, x is equal to 1 by 2, 3x minus 10 is equal to 0, x equal to 10 by 3. Problem is solved. And there is one more type which is important, because in most cases you don't get a factorized one or an identity. You get an equation which cannot be factorized. In such cases, what should we do? Let's see. Last but not the least, a problem which can't be factorized. These type of problems can be solved by using this formula. And this is the ultimate weapon to solve any kind of quadratic equations, and it is given by x equal to minus b plus or minus under root b square minus 4ac by 2a. You should remember this. And coming to our problem, in the terms b, a, c, these all are the terms like the given equation will be ax square plus bx plus c, and this b and this a and this c, they must be substituted in this order only. Coming to the problem, 5x square plus 11x minus 12 is equal to 0. You can check, it cannot be factorized, and I am taking the values a as 5, b as 11 and c as minus 12. Remember, you should take these signs. Just substituting the values in the given equation, and the remaining part is all calculation. X equal to minus b plus or minus under root b square minus 4ac by 2a. Minus b minus 11 plus or minus under root b square 11 square minus 4ac 4 into 5 into minus 12 by 2a 2 into 5, and then minus 11 plus or minus 11 square 121, minus into minus is plus, 4 into 5 20, and 20 into 12 240 by 2 5s are 10. And solving it, minus 11 plus or minus under root 361 by 10. 361, its square root is given by 19, which means minus 11 plus or minus 19 by 10. And many students think that plus or minus, what to do with it. We should plus or we should minus. The thing is, you should be doing both of them. As I have told you earlier, for a quadratic equation, we have two solutions. So, and also this is a square root. For every square root, we have both plus value and minus value. 2 square is 4, minus 2 square is also 4, which is why we have taken plus or minus. And then coming to the answer, 19 minus 11, 8 by 10, minus 11 minus 19, minus 30 by 10, 4 by 5 and minus 3. This is the pair of solutions which we need, which satisfy the given equation.